The first example I want to look at is 4x plus 2y equals 6 and negative 2x minus y equals negative 2. We want to solve this system using matrices. We also want to see, is this system consistent independent, consistent dependent, or inconsistent? The initial matrix let's see. Well, the first row is going to be 4, 2, 6, and the second row is going to be negative 2, negative 1, negative 2. Remember, our first goal is always to make D11 equal to 1. Right now, D11 is 4. Excuse me. Notice that this time, in order to make D111, we're going to have to multiply by the reciprocal of the current D11, which will be 1 over 4. So we're going to use the command 1 over 4 times R1 will give us a new R1. So that our matrix becomes, let's see, 4 divided by 4 is 1. 2 divided by 4, let's see, we've got to simplify that. 2 divided by 4, that's the same as 1/2. And 6 divided by 4, if we divide both of these by 2, we get 3 over 2, so 3/2. And then the second row is still negative 2, negative 1, negative 2. Our second goal is always to make D21, the element right below the one that we just got, equal to 0. Well, that means we're going to add the opposite. So we're going to add positive 2 times row 1 to row 2 to get a new row 2. Let's do this right here. So let's see. We've got row 1, 2 times row 1, row 2, and the new row 2. Row 1 is currently 1, 1/2, 3/2. 2 times 1 is 2. 2 times 1 over 2, let's see, 2 times 1 over 2, well, that's 2 over 2, and 2 over 2 is 1. That's nice. And then 3 over 2 times 2, well, if we just multiply across, we get 6 over 2, and 6 divided by 2 is 3. Okay. Row 2 is currently negative 2, negative 1, negative 2. And when we add these, let's see, 3 minus 2 is 1, 1 minus 1 is 0, 2 minus 2 is 0. So our new row 2 is 0, 0, 1, and our matrix looks like 0, 0, 1, and row 1 is still 1, 1/2, 3/2. Let's look at what we've got. If we wrote the equation for this second row, we would have 0 times x from the 0 here plus 0 times y equals 1. But on the left side, 0 times x, 0 times anything is 0. So this is going to be 0. And then 0 times anything again is 0. 0 plus 0 is 0. But that is supposed to be equal to 1. Since this is never true, then these two lines must be parallel. So let's take a look at that. Let's graph the system 4x plus 2y equals 5. No, it was 6. And negative 2x minus y equals negative 2. So let's look at line 1, and we should have done that in orange. So here's line 1. For line 1, we want to write line 1 in slope-intercept form. Which is y equals the slope times x plus the y-coordinate of the y-intercept. That means we need to solve for y. So we currently have 4x plus 2y equals 6. We want y alone, so let's move the 4x to the right side of the equals by subtracting it from both sides. Now we have 2y equals negative 4x plus 6. We almost have the right form, but we need to divide by the coefficient of y, the number in front of y, because 2 divided by 2 is 1. On the left, we just have y now. Let's look at the right side. Negative 4 divided by 2 is negative 2. 6 divided by 2 is 3. And that means that the slope here, well, that's the number in front of x, or the coefficient of x, that's negative 2 over 1. And the y-intercept is 0, 3. All right, so let's see. We've got the y-intercept is 0, 3. And we go down 2 and to the right 1 for the slope. So down 2 to the right 1. Here's our line 1. For line 2, let's see, line 2 was negative 2x minus y equals negative 2. Negative 2x minus y equals negative 2. So let's move this negative 2x to the right by adding it to both sides. That leaves us with negative y equals positive 2x minus 2. And now we need to multiply by negative 1, which is really the same as dividing by negative 1. Multiplying is easier. So now we get y equals negative 2x plus 2. That means that the slope here is negative 2 over 1, and the y-intercept is 0, 2. Okay, so let's see. Here's 0, 2. The slope was down 2 over 1. There's line 2, and you can see that they are indeed parallel. They both have a slope of -2, -2/1, but they have different y-intercepts. So they are different lines, and they are parallel, so no solution. A system where there is no solution is called inconsistent.